Hey guys, in this video we're going to take geometric solids and we're going to just get some more practice. We're going to move it on and make it a little bit harder and move on to harder examples. So, geometric solids 2 I'll call this. In the previous class we would have worked with some of the more basic objects, and today we're going to move on to some of the harder ones here. And just a little bit harder. I'm going to start off with you. There's two examples shown here on page 220 of your book. I'm going to set up both this guy and this. Or where are we? Yeah, let's set it up. This, I'd like to get 1, 2, 3. Sorry for a second, I thought they were the same. They're not, of course. So we have a rectangular based pyramid here being cut by our simply inclined plane. We have another similar rectangular based pyramid here. And we have a square based, I think, down in this one, but it's just turned in different orientation. So I'd like to get through the 3 of those. What we're being asked in each case is draw the elevation plan of the truncated pyramid and draw an end elevation. So I'm going to keep, I'm going to keep the space on this one here. I'll draw the elevation, the plan, and I'll look across. Look in from the left and the view goes on the right. So I'm going to start this drawing here up in the top left corner of my page. I don't know if I'll fit 2 or 3 onto the same page, or would it be all ones. But starting off up here, there's a 22mm space into the starting point. Okay, now there's a 22mm space, but it's not all that easy because we actually need to start with a point like this one here maybe, and then go up to 25. So I'd often be just looking at these and saying, like, if that's 22, then that's probably about another 30 or more, so 52 total. So if I come in 65 or 70 in here and then down to 25, I need to make sure I leave 125 at the top minimum. So I'll come in 70 from the left hand side. In 70 from the left and down 125, down 135 maybe or something. It's actually a large drawing again. Down 135 there. In 70. And that can be the start of that point in the plan. And on the plan there it's 65 by 90 and that's 60 degrees. 65 that way. 90 that way. All these measurements are, of course, in your book anyway. So 65 one way and 90 the other, and it's all set up at 30 degrees and 60 degrees, just like that. And the outline of this does not change, so that the plane does not cut the object on the ground. It just cuts the specific heights, which we'll be able to establish after. So the outline doesn't change, so I'll just heavy that in. Just in light detail only, I can just put in these guys here, the edges that go up to the apex or the vertex, and I'll keep it light because they do actually change. Now I'll project all 4 base points up. They'll be just hitting the XY line, which I need to draw in there in a sec. There's all 4 base points, and I'll take up the apex. Gave me a distance, didn't it? Yeah, 25mm. The distance up here to the XY. The XY is going to be quite large. It's going to have to be enough to take in the end elevation as well. And the altitude is 100. And once again, the base profile does not change, so I can heavy in from here to here, but all of those edges of the object itself probably will get cut by the plane, so I'll just keep them light at the moment as well. Right, next they gave me 22mm across here, so I measure 22. Not in the corner. And the plane, this is called a simply inclined plane, cuts through the object just like that. And the second line or trace just looks like that. So the plane is basically, as we see it in the elevation, it's striking straight through the object. As we see it in plan, it's lying down at 30 degrees up from the ground, cutting through this pyramid. I always call the apex there point 0, okay, just a habit. And I'll label my 4 edges, so 0 goes down to 1 on the ground, it goes down to point 2, down to point 3, and down to point 4. And I've labelled those in elevation. 4's here at the front with me, 1 is here at the left, 3 at the right, and 2 at the very back of the object, so that's going to be my hidden detail. And now I can see exactly what's happening. Now I can take my pencil and I can actually heavy in the edge that remains. I have 0 to 4 here. I have 0 to 1 here on the left side. And I have 0 to 2. It's at the back of the object as I'm looking at my elevation, so that means it must be hidden. Now the handy thing here about finishing the plan is if you can see all of the points where the edges get cut. I should also probably do this now before I go any further. You want to see the top surface, like that's the cut surface. But if you can see all of the points where the object gets cut, well, you can just project them straight between your views. I mean, if edge 3, 0, 3, the line gets cut right there, that's it, that point. So I'll drop it onto the line. Edge 4 gets cut here. And this is where labelling comes in handy as well, because, you know, if I don't label my points, there's a chance I could drop projection onto the wrong line. There's number 2, and finally, there's number 1. So I get my 4 cut points down there in plan, and I just join them. And that's what the cut surface looks like now. That plane results in a cut like that. And the remaining edges of the pyramid, they need to be just heavied in. And that's that part of the drawing finished. So that's only part A of this drawing finished, I suppose. Draw the plan and elevation of the truncated pyramid. Part B then is to draw an end elevation. In the end elevation, we'll just project, first off, taking points 4 on the ground, point 1, the apex, and point 2, and projecting up onto the XY line. Don't forget point 3, which is already across here on the YY. The only one that has a height there is the apex. The heights come from the elevation. Some people might wonder, like, what was the point in taking the apex when they're not actually part of the question? And it did right to say that, like, you actually could do this whole question outside the whole end elevation without having an apex over here if you wanted, and it would work out just fine. You could project all your other points from plan and from elevation. So let's say what I mean by that is this point here where the edge 3 gets cut, you can project that point across and up, and it would land you on the same one. But this is the way I prefer to do it. I prefer to label my points as I go. That's 4, that's 3, which will be hidden because at the back of the object as we look this way. That's 2 here on the left, and 1 is here. And I have my 4 edges. So where does point edge 4 get cut? It gets cut here. So I'll take it across to hit. Where does 3 get cut? That was 3, wasn't it? Yeah. Where does 2 get cut, which is the one here on the far left. And finally number 1 is the one here right of centre. And Watch out for your hidden detail this time. Now, first thing I'll probably know is that the external ones aren't going to be hidden. They're kind of showing the far right and far left points. What is hidden? As I look in this way here, 1, I can see 1 straight away and 3 is at the back, and it's the same in plan as I look in this way. 1 is right here in front of me, 3 is at the back of the object. So edge 1, it's just that small one, but edge 3, and then I join the dots over here, so 1 to 2 to 3 to 4. They're all 4 cut points. There we go. That is our cut surface. We haven't been asked for a true shape this time, so we don't need to do it. If you were asked for a true shape, you could, from the point, rabat out. Now I'm obviously running out of space here, but what you could also do, just as a little extra here, why rabat out when we can just rabat in? And I know it's going to cover the original drawing, it doesn't matter. You could rabat in. So if you just add this onto your drawing for me, please, rabat in your 4 points. Down onto the horizontal plane or down onto the ground like that. I'll pick a different colour here for this job. I rabatted in point 3, it landed on the ground there. In with point 4 here. In with point 2 and in with point 1. And as I said to you in the previous videos, everything moves perpendicular to the hinging line. That was my hinging line there. And this time, instead of swinging the whole thing out, we just kind of caught it and dropped it down. And perpendicular means perpendicular to the line from point 1 out onto the green. Perpendicular again. 3 and 4. And yeah, the true shape then, if I just put it in dark green here, the true shape is just those 4 points joined up again. So there in dark green is the actual true shape this time, without having to stick on extra pages or anything like that. There's the true shape laid on over it. I'm going to get one more done. I think that'll be enough for this class. I'll just flick this over actually. Save the paper. Now, what I want you to do is try this one on your own, okay? And there's a graphic shown here, which should help you along the way with it. And I'll do the last, or will I? No, I'm going to do this one, and you do that one on your own, simply because that's given as an example and it's worked through. And for this one here, what you'll find is when you're doing this yourself after, 2 points which are cut right there, you have 2 different methods of finding those. You might need this horizontal section here, which you'd have practiced in previous questions from other topics even. A horizontal section to find those points will find you the little diamond here in plan. Or, as they do it here, just draw the end elevation. Draw the end view over here and bring the points back down to plan. So that's for you. This is for us now again. So starting off this question, this is more basic, an 85 by 55 rectangle, up 30, up 80. So I'll start off there by drawing the I'm going to start off again by drawing the plan. They're asking us for an end elevation as well. So this time I want to leave space so that I'm looking in at from the right so that I can see the cut surface. I'll draw the end elevation on the left. So I'll just start off over here at the right side of the page anywhere at all. I don't think this question is as big at all. I'll start off there with the 85 long. 85 long, 55 feet plan. And the base of that plan, on this side anyway, is full. On this side it is cut. So I'll keep it light. This side is cut. Top side here is full solid. I'll join my diagonals to find the apex. They're giving me a space of 30 between the views. And then the height. So project up the base points first. And the height was, what, 80 I think, wasn't it? Height of 80. Now, there's a 24mm measurement given here to the right, 24, and that defines a point on the cutting plane, and that plane cuts at 45 degrees, just like this. So it cuts through the whole object there, and it just stands up straight. Okay, so labelling again will come in handy here. So from 0, which I'm drawing the apex, down to 1, down to 2, down to 3, and down to 4. They're the first ones I'll do. So 0 is the apex, down to, that's 1 and 2, and that's going to be 4 and 3. I do that because 4 is at the front and 3 is at the back. So as I look in at the object, 4 is the one out near me, 3 is the one at the back. Right. Show my cuts, but before I do, actually I might even start heavying in what I can heavy in down here. So that base edge there is heavy. This whole edge here to the left is heavy. That portion out to 3 there should be light, actually outside the plane because it's cut off. And then part of these diagonals here are the edges that go up to the vertex. That part and down to 2, and then from here just to the left of the plane only. Heavy. First thing I'll do so is I'll find the points where, what are my two edges, 0,4 and 0,3. I'll just find the points where they get cut up here in the elevation. So 0,4 gets cut there, right up at the top. Cut 0,4, and then 0,3 gets cut down here. Cut 0,3. There's nothing wrong with putting these labels on and notes on, by the way. You are welcome to do that anytime. It gets cut on the ground down here, and it gets cut on the ground out here. And that is the cut on the line 1,4. And that is the cut on the line 2,3. How do we work with them? Well, we join all the dots. So the way that this one is going to work, it's going to go from the cut point there on 1,4, and it's going to go all the way up through this triangular face up to this top point here. What remains? Well, the vertex down to 1 obviously still remains here on the left, and the vertex down as far as that cut number 4, or cut 0,4 as I'm calling it, remains. And along the ground it remains all the way as far as here. It goes from cut 0,4 right down through the face to cut 0,3, which is just all in line with the edge again, and it goes from cut 3 down to the point on the ground here. So the actual section of what we're looking at here is this guy. That's what we're looking at. That is the cut section this time, a little bit different looking to before. And the simple reason it is because it grounds itself twice. It goes down to ground 2 times, unlike some previous examples which might have not been grounded like that at all. So there's the cut surface. Time to project an end elevation. points 1 and 4. That's 2 and 3. And then we have my apex as well. I'll take my apex across. I'll join it down to points 2 and 3 down here. And down to points 1 and 4 down here. And then it's time to take my cut points across, so 2 and 3. Or do I need to take them from here? Probably not, you know. I could actually make this easier by taking them all from the elevation. So that's 3, 2 right there. And that's 4, 1. And that's 0, of course, up top. And then my cuts. This cut's 0, 4, which is out there. This cut's 0, 3, which is here on the right. Now, what remains? What remains is I get the cuts on the ground. And this one is going to take a little bit of thinking about. But what we need to realise is that the full surface here, or some part of that surface still remains. That's from 0, 2, 3, let's say. If any part of it remains, we have to draw it, the whole thing. And again, some of this guy remains, especially all of 0, 1 remains here. So as we look in at this view, the full object can actually be seen. And the cut surface is all part of that. Okay. And the only thing that we can actually draw in here, because this cut here, let's say down through this triangle 0, 1, 4, because that cut is just part of the surface and the rest of the surface is still there, we can't make any changes. But all we can do is this. We can join across this front surface. So as we look in right here, what remains is from cut point 04 to cut point 03. We can just join those guys across just like that. And that's it. There's nothing else we can actually show over here. That is my cut surface again. Right there. No true shape needed. There's the cut surface as it appears in one view. There's the cut surface as it appears in the elevation. And that's another example of geometric solids. So for this lesson, you'll have done 1 question yourself based on the example in the book and 2 with me. Thanks for watching, guys.